Okay, chapter 4, section 6 is proving triangles congruent using ASA and AAS. Before we even talk about that, let's talk about which methods have we learned up to now. At this point, we've learned a few methods. SSS, SAS, and HL. Two more that we're picking up today. Now, these are all shortcuts so that you don't have to prove every single part of every single triangle is congruent to each other. Today, we pick up ASA, which stands for angle, side, angle, and AAS, not to be confused with the bad word. Angle, angle, side. That's two A's, not two S's. Okay, so these are going to be two other methods. I'm sure you could probably figure out by now two other methods that we can use to prove that triangles are congruent. You could use any of these. You can use SSS, SAS, HL, ASA, or AAS. All of these are acceptable ways to prove that triangles are congruent. So the ASA congruence postulate says that if two angles and the included side, remember that included side is the side in between two of the angles that we're talking about, of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. So what we're looking at here is, sorry, I'm just trying to get that on the screen. There we go. What we're looking at here is we've got, from the diagram, what we are given is that angle A is congruent to angle D, just by looking at the pictures. Angle C is congruent to angle F. And in between A and C is an included side. We call this the included side again because it's in between the two angles that we're interested in. They gave us two angles, we're interested in those two angles, and in between them is a side. In between the other two angles that we're interested in, there is also a side. It just so happens that they are congruent to each other. So what we've got is ASA. ASA. This is enough to prove that these two triangles are congruent to each other because in between the two angles, we've got, let's see, that's side AC is congruent to side D, oh, that's not a D, side DF, and then we also had angle C was congruent to angle F. And that, my friend, is ASA. Yes, ma'am?
Just use the third angle here.
Well, we could, but remember, so she's saying, why not just use third angles theorem to prove that the third angle is congruent? Sure, but what is not a thing is AAA. That's not a thing. So even if we did, it wouldn't help us out. You know what I mean? Like, let's say we did. You're not wrong. So she's saying this. Isn't it true that this is congruent to this? No doubt. She's 100% right. But how did that help us? You know what I mean? We've got three angles where three sides is a thing, three angles is not a thing. Angle, angle, angle is not a way to prove congruence. I'm glad you brought it up, though, because it's actually a direction that a lot of people try to go, so it's kind of good when somebody does, because it's like, yeah, we can't do that.
So is the included side just the side in between whatever two angles
Mm-hmm.
we talked about?
Yeah, like if I've got, like notice I've got A and like A and C are two angles that are marked on one triangle. D and F are those same congruent triangles on the other. It's the side in between those two angles, the side that connects those two things. That's our included side. Just like an included angle would be like the one that is pinched between those two sides. Thank you. Okay, and then there's AAS. AAS, if two angles and this is so important here, and a non-included side. Remember when we had, just a moment ago, when we had angle, side, angle, the S had to be included. It had to be in between the other two. In this one, the side is not included. It's not in between the two A's. So if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the triangles are congruent. So here's what we've got here. Angle matching angle. Let me just color code those. Angle matching angle. Another angle matching another angle. Now on AAS, notice that the S is not in between the two A's. I do not want the included side. I need either one of the sides that are not included to be congruent. And that's what I've got here. The one that is touching the one with 2 marks is congruent to the one it is touching with 2 marks there. Same exact pattern. It's a non-included side. It also happens to be the corresponding piece, meaning it's in the exact same position. And how did I know that? Because the one on the left was touching the angle that had the double bars, and the one on the right is a side that is also in the same position because it's touching the one that has the double bars.
Even if the side isn't corresponding, does it matter?
So yeah, they need to be the corresponding. They need to be corresponding, but they also need to be the non-included side.
So like that,
We would have been fine with this too instead. We could have also had that one. Like instead of the green one, we could have had that one. The one that we couldn't have is JG, the one that's in between those angles. If we did, actually it would still be congruent, but it would not be like, so let me just take this away for a minute. If instead of that, we had this side being congruent here, imagine that this wasn't here, okay? Pretend that's not there for a second. And imagine that the 2 blue lines were congruent, then it wouldn't be AAS. What would it be? ASA. Yeah, because it'd be an included side. So here's part of the thing that you need to be able to recognize it, because you may be able to mark all the things that are congruent, but if you don't know how to identify them, that's going to mess you up on the proofs. You need to know, what is that? ASA, AAS. In this case, the blue line was not the one that was congruent. It was the green line, bless you. So we've got AAS, the non-included side. Okay, we're almost to our proofs here. First, quick summary. These are our 5 ways that up to now... Oh, why is my thing not reflecting? Oh, there we go. 5 ways that we have up to here. Like, this is where we're at now. We started with SSS, meaning all 3 sides of one triangle were congruent to all 3 sides of another. Now, one thing it does not mean these triangles are equilateral. So we got to be careful with that term. A lot of time people say equilateral. Yes, all the sides of one are congruent to all the sides of the other, but the term equilateral means on one triangle, all of the sides are the same. Like, it would be like if the sides of a triangle were 5, 5, 5, 7, 7, 7, 9, 9, 9, 100, 100, 100, whatever it is, they're all the same thing for equilateral. This just means that one side matches another side, a second side matches a second side, and the third side matches a third side. SAS, we've got 2 sides of one triangle that match 2 sides of another, and we definitely have an included angle. Remember, it's the angle that is being pinched by the 2 lines. That's what we're looking at there, the included angle for SAS. Yes, ma'am? Yeah, I just need to see the note before you go. Then we've got HL. HL can only be used in what kind of triangles? Right triangle, because it's the only one that has a hypotenuse. Nothing else will have a hypotenuse but a right triangle. So the hypotenuse and the leg is all you need. But you must guarantee me that it is a right triangle first. ASA, where we have 2 sets of congruent angles, and the included side, the side that is in between those 2 angles. And now we've got AAS. Angle matching an angle, another angle matching another angle, and there is a side, but it cannot be the included side. If it's the included side, well, then we've got ASA. That wouldn't be AAS. 5 ways. So really, this is going to be kind of like your cheat sheet of things you're going to use. So if you're doing homework and you're forgetting, like, what can I use? You might want to screenshot this and just paste it right in there. It's a quick little reminder of, well, what can I do? What are my options? And then kind of comparing it to these. And now it's time to proof it up. 3 proofs, and they're all kind of fun. All right. We need to prove that triangle XYZ. I'm just going to go ahead and outline these here so we can see what we're talking about. XYZ. X, Y, Z, that triangle there, is congruent to V, Y, W. V, Y, W. That's what we're trying to prove. I'm going to go ahead and mark all the things that they're telling me before I even start writing this proof. I'm just going to look at it and say, okay, well, I know that x is congruent to v. Here's x is congruent to v. I've got angle YZW. YZW is right here. It's not even inside one of those triangles. It's congruent to YWZ, this one right there. Okay, interesting. That one's not even in the triangle, so that stinks for us because you're like, oh, well, that doesn't help me a whole lot. And then I've got XY, line segment XY, is congruent to line segment VY. Now, again, make yourself a note. Like, let's say you're doing a proof. Here are going to be my options that I can use. I've got SSS. I've got what else? SAS. Other options, there should be 5. AAS. HL. And what are we missing here? ASA. Knowing those 5 things. Now, I'm guessing that there's one of those 5 that I can throw away from the beginning, just because it doesn't even look like it would work on this one. HL, like that seems like we can go back and revisit this if we prove that I'm wrong, if we find a 90-degree angle in there, but I don't see any 90-degree angles, and if this picture is accurate, then it's like, I don't think that's going to happen here. So, let's go through this. Based on what we're seeing there, what are some things that it's not going to likely be? Now, again, let's not sit there and try to work the whole thing out, but likely it's probably not going to be which one? Was there anything that's not probably going to be? ASA, so if it was ASA, it's very possible it could be ASA, because if we could prove this one was congruent to that one, we would have ASA. So maybe. I feel like that's a maybe, because if I could prove that, the one thing, then that's a maybe. Side seems very far-fetched, because that would mean I'd need a lot more. I'd need to prove that the other 2 sides. So I feel like this is probably not a good choice. SAS, maybe, because I would only need this side to be congruent to that side. That's a maybe. AAS, maybe, because look, if I only had this angle here, if I only had this angle right here, that one right next door to the angle that they gave me, then that would be a possibility. And ASA, which is the top one up there. So really the only ones that I feel like no way on HL. Probably not on SSS, but I'm down to one of those 3. And of those 3, I feel like they kind of gave me a hint as to what I might be doing. And again, I'm not trying to guarantee that I'm doing anything. Anything by looking at what they gave me, especially because they gave me this, makes me feel like I kind of have a feeling where they're going to have me go with this.
Maybe angle side.
That's what I'm thinking too, and here's why. Here's why we're thinking that. This over here, this angle right here, is probably going to lead me into that angle there somehow. And this angle here is probably going to lead me into that angle right there. And if I can do that, like what they're doing there, then it'll probably be AAS. So that's what I'm just going to go along, is that route right there. So let's start proofing it up now, because this is all we've got. Let's do our statements and our reasons. I'm just writing my givens here. Try to get your givens on one line. A lot of times people break the given up to like try to get themselves more room and be like, oh, well, this takes up more lines. It actually probably doesn't work so well for you because I usually put it on one line unless there's for some reason like it's easier to break it up to show you something. That's given. I just want to get all my given out there because that's what I drew on my picture there. Now, let's talk about the one part that is interesting. The one part there that it's like, what the heck? Why did you do that? Where is the what the heck part on this one? Like, what is the, like I get why they gave me an angle inside the triangle. I'm probably going to need that. I get why they gave me a side, but what am I not getting yet? These angles on the outside. Okay, so let's see if we can do something with these angles here. Something. Yes, ma'am? It could be, except for we don't have any numbers. So you know what I mean? It's like, it's hard to add up things that don't have numbers. It would be like this one plus that one, and there's no numbers involved, so.
Angle YWV is congruent with angle YZX.
Okay, so, but we've got that here, right? Like y, that's YW, oh no, we don't have that yet. So, but how would we know that? He's saying this, let me show you what he's saying. He's saying this right here. I don't disagree with him, but I do disagree if we can't show it. Like, we're going to need to show that. So we better have, even if we can't explain it in nerd speak yet, like, let's talk about it in human speak. Like, why would that be true?
Should we figure out what YWV and YZX is to YZW and YWZ?
Okay, so I'm seeing a pattern that you guys all want to go into, and I kind of agree with it. So here's what you guys are all kind of wanting to do. We all kind of agree that we want this angle here to match that angle there. Do we agree? We all kind of feel like that's where we want to go. So maybe we could make some sort of connection here and some sort of, so connection here and connection here. If we could do that, maybe there's a way to bring this all together.
Could it be the angle addition postulate, something like that?
It could. This is not just any old angle though. This is a very special one. They are linear pairs. So let's talk about the one on the left first. Let's just go left to right. We don't have to. I've got angle XZY. That's this guy right here. I'm just marking it there. I'm not trying to show they're congruent yet because I'm not there yet. That's, here, I'll highlight it. How about that? This angle here, XZY, plus, I didn't mean to change colors, plus angle YZW is going to be equal to what? 180. But that's not the only linear pair I've got, right? I want to talk about the other linear pair too, the one on the right. And let me talk about that one. I've got angle YWV, that's this one right here, plus the one on the other, I keep doing that, plus the one on the other side, which is Y angle YWZ, and they will be equal to 180. They are a linear pair, and the linear pair postulate says that if you've got two angles that form a linear pair, they will add up to 180 degrees. That is the linear pair postulate. And all we're saying there is that there is a linear pair here, and there is a linear pair there. That's what we're addressing. Yes, ma'am?
Could you now say that angle XYZ plus angle YZW is equal to angle YW?
I love everything you're saying. Let me write it while you're saying it. So talk to me so maybe that people see where you're going here. Say it for me one more time.
Okay, so angle XZY plus angle YZW
She's doing this right there. All she did is repeat that.
is equal to angle YWV plus angle YWZ.
And why would that be true? It is true. Why?
Oh, because both of them are linear pairs and they equal 180. So if they both equal 180, one should be equal to the other one.
Good. Do we have a term for that? What is it? It's a transitive property, or the other name we could use? Substitution. So I'm just going to write substitution or transitive property, whichever one you were kind of leaning to there. Now we made a connection between those. There is a connection between those angles. Now, ultimately, what we are going to try to say is that if we can say that angle XZY, this guy right here, let me just clean some things up here. I'm sorry, it's getting a little ugly here for me. If we can say that angle XZY, this one right here, is congruent to VWY, this one right here, then we've got everything we need for AAS. Okay. All right, so here we go. We are here, and we are trying to get x, z, y. Okay, so we're trying to get this one equal to v, w, y, this one right here. That's what we want to be left over with. I would like a statement that just said that is equal to that. Yes, ma'am.
Did you say angle XCY is equal to angle YWV? That's subtraction, because you just subtract angle YZW from both sides.
But notice I don't have YZW on both sides. I would love it if we had a way to get YZW on both sides, just like you said. I wish I had a way, but unfortunately there's no hints as to how we could possibly do that. There's no way. Amber, you got something for me? I don't see it. I don't see any possible way that I could make them both a... What?
That angle YZW is equal to angle YWZ.
How does that help me?
Because then you can cancel them out. Because of maybe transitive.
Well, what I'm going for here, right, is I love what you said. Let's subtract away the same thing from both sides.
For substitution.
Ah, I love it. So she's saying that one of these two things needs to change. One of these two things we want to get rid of needs to change. One of them. Because if we can change one of them so that they're exact same thing, then we can subtract it away. So we want to keep the x, z, y. We want that because we want that to be the same on both of them. And we want to keep the y, w, v. But we can change either one of these. Since substitution was your idea, which one do you want to switch?
The second one.
Okay, so we're going to swap this one out. Sorry, let me change colors just so we're seeing. She wants to swap this one out. So I'm going to leave the first one the same. Plus y, z, w. And we're going to take that y, w, z and exchange it for a what?
YZW.
A YZW. Now we have the same thing on the both sides. Okay, great. We did that. What was our reasoning for being able to do that? Like, what did we just do there? Substitution. We did substitution to get there. All right. Now, what did we say we were going to do? What was the whole purpose of that? To subtract. So we're going to subtract away the YZW, leaving me only XZY is congruent or equal to YW. Oops, that's not a Y. YWV. And that was subtraction. That's how we did that. So now, we got that yellow angle we were looking for. We all agree that that yellow angle is now handled. So, the red triangle and the blue triangle, are they congruent? Like everything I have drawn up there is now true. Why is the red triangle and the blue triangle congruent? Angle, side. Two angles with a non-included side. So I'm going to say triangle XYZ is congruent to triangle VYW angle, side. Not easy, right? But I mean, it's kind of cool when you get it, like when you see it and you're like, oh, yeah, I get it now.
Can you zoom in a little bit on the third one up?
How's that?
Yeah.
I'm going to put it on pause so everybody can catch up here. All right, moving forward. Good news is the second proof is way easier than this proof that we just did. The third one's a little bit difficult too. 1 and 3 are difficult, 2 kind of easy. All right, here we go. I'm just going to draw in the things that they ask me to do. It says that JL, this line right here, JL, that one, it bisects angle KLM. What the heck does that mean? What the heck does it mean if it bisects that angle?
It goes right through the middle.
Okay, so what does it do to it then?
It splits it in half.
Okay, it splits in half. Well, how did that help me?
It means it's congruent.
Yeah, it means these two sides here, this and this, are definitely congruent. Notice we haven't even started proof yet. We're just talking about what does that mean. And angle K is congruent to angle M. That was already marked on there. And we are trying to prove that both the top triangle, JKL, and JML, the bottom triangle, are congruent. Okay, well that's pretty much all I got. I need some statements, and I need some reasons. And I don't think you actually need me for this, so I'm going to do my best to shut up, but I'm kind of noisy, so we'll see. Where am I going from the beginning? Let's write our givens. JL bisects angle KLM. Now remember, you guys told me about that in plain English. We're going to need to actually turn that into nerd speak here in a second. All right, that was given. All right, beyond that, now we got to start talking about what things do we know.
JL is congruent to JL.
Okay, line segment JL, thank you, is congruent to line segment JL. That's this. He's saying this right there. Why?
Reflexive property.
That's the reflexive property. POC, property of congruence. It means that that line is congruent to itself. All right, well, you guys told me something that we haven't addressed yet. You told it to me in plain English. We just haven't addressed it in like math speak yet. Like we talked about what it means. Now we just need to turn it into like actual math speak. Yes, ma'am.
Angle KLJ is congruent to angle MLJ.
Let's talk about why. Yeah, definition of an angle bisector. That's the definition. You guys just took that and took what it means. Definition of angle bisector. So everything that is drawn on the picture now is now explained on the chart on the right, on the two-column chart. So what else do we have to do? Yes, sir.
You can now say that the triangles are congruent because of AAS, yeah.
These two triangles are congruent because of AAS. Two angles are congruent with a non-included side, that is AAS. I thought that one was way easier than the last one. We're talking about those K and M are congruent, and KLJ, this top part there, and the one right below it, which is MLJ.
Yeah,
This.
like which one are we talking about when we say that it's not possible?
So see those two angles? They're congruent to each other. And these two angles, they're congruent to each other. That is two angles. And the side that is right here is congruent to each other. It's a non-included side. Notice the S is not in between the two A's. That's AAS. All right. Here we go. We're going to identify the postulate or theorem that proves the triangle is congruent. So we are not going to do a proof here. We're just going to look at the triangles, see what is true about them, and then decide how we would determine whether they are congruent or not. Talk me through it. Yes, sir.
ASA.
Okay, so why ASA?
Because 150 and 150 are congruent, and 15 and 15 are congruent.
So,
We already know that that line is.
perfect. An included side, angle, and included side. This is definitely ASA. Two, I could use two different methods on this. Yes, sir.
Or I use AAS.
He used AAS. Talk to me about AAS.
So on the left side, the congruent to the right side.
What do you mean left side and right side? Oh, this side here?
Yeah.
Okay, that's congruent to that. Okay, so there's definitely a side.
And then the bottom sides are congruent to each other, and this side is 90-degree angle.
Okay, so we've got two sides. And then another angle.
Yeah, no. SAS, yeah, I'm sorry.
Well, I would disagree with you for saying SAS. Why would I disagree? Even though he's got two sides that are congruent and an angle that is congruent, why would I disagree with SAS? Colette?
Because they're not included.
That's not an included angle. So that's actually, good thought, not what I would do. And here's the dead giveaway. If I looked at this, I have two S's and an A. Imagine if I read this either backwards or if I put the A at the beginning, I've got that bad word in geometry that is not a thing. So there you go. Not that one. Yes, ma'am.
HL.
Let's talk about HL. Why HL?
Because they're both 90 degrees right triangles.
These are both right triangles, even if you don't see the little box there. That says 90 degrees, so that's definitely true right there.
And then their legs are congruent, which is the side at the bottom.
Okay. Legs are congruent. We see that.
And then their hypotenuse is congruent
How did you know that this side was the hypotenuse?
because the right triangle is pointing at it.
Yeah, it's like a right triangle that points, the little right angle points at it. So if you ever get lost as to which one's the hypotenuse, use those little arrows. Those are the hypotenuse. HL is definitely one way of proving these are congruent. Yes, ma'am.
SAS would also be used because the line in the middle is congruent to itself.
So SAS?
Yeah, because then the bottom line in the
Let me tell you how impressed I am. That's a third way that I just didn't even think of. So check it out. I didn't even think about this. I went a totally different route, and it's not even one that she's about to say something that I didn't even think of, and she's totally right. So check this out. I'm going to do exactly what you said. The line down the middle is what? What were you going to say about it?
congruent to itself.
It's congruent to itself. Okay. And now talk to me about what you're saying. You're 100% right.
And then the bottom angle and that angle can be like an included angle there.
Here, the 90 degrees is now included between the green and the blue line. So SAS, in fact, would work, which is one I hadn't even considered. Bravo. I didn't even think about that. What I had considered was something else. Colette, do you consider something else?
Could have been SSS.
I was considering SSS because as soon as we drew in that third side, I didn't even bother thinking any more forward. I had SSS. So, but SAS would work too. All of these are acceptable ways to call these like that. Okay, these are congruent triangles. Yes, ma'am.
I'm still confused on how it's SAS. Like, I don't.
Okay, so when she did SAS, she's basically ignoring, let me kind of go back for a minute. She has chosen to, and there's nothing wrong with this, she's choosing to ignore this line entirely. She's not even going to pay attention to it. So she doesn't even care. She's not going to use it. She's not going to use it so much that she doesn't even look at this. So pretend it's not even there for a minute. She's not even caring about that. She's looking at the line in the middle and saying the reflexive property allows me to say that this line is congruent to that line. Would you agree with that? And then she looks at the bottom one and goes, oh, yeah, well, this one is congruent to that. And in the middle, I've got this 90-degree angle congruent to the 90-degree angle. This is SAS. Something I hadn't even considered. So, listen, I am not going to have every perfect answer, but that was a third way. When I looked at this, I did, there's two ways. But that's because I hadn't even considered the third one. Then it's like, oh, yeah, we could look at it as the SAS there. All of those would work. How about number 3? I've got at least a couple ways on this one as well. Yes, ma'am.
Alright, so I do side and the side.
Okay.
Because there's a vertical angle, 2 vertical angles there. Between the 2 sides.
I'm just labeling what she's doing there, just so you can see it. She's got those 2 angles as congruent.
And then you have the side, the angle, the side.
Side congruent to side congruent to side, with an included angle in between. That would definitely be side angle side. Are there any other ways that I could do this?
You could do side, with the middle line congruent to itself.
Perfect. Maybe you just focused on this and said, well, this one's congruent to itself. That's side, side, side. So you let me worry about sorting it all out at the end. That's my job, to go through the proofs and sort them all out. I have to follow exactly what you were thinking, but that's why it's important for you to show me what you were thinking so I can follow it and see whether there's logic to it. All right, time for our last really fun proof. Okay, I need you to make a change on this. I found a mistake on this, and I need you to make a change on it, or this will not make sense. Take DCE, cross it out. Change it to EDC. I need you to make that change, or none of this will make sense. I sat there running my head around in circles for hours going, wait, what happened on this? This doesn't work. And then I realized that there was an error in how that was written. Okay, let's talk about what they gave us, and let's just draw it in. FAB, GED. FAB is here. Oh, another angle outside of triangle. I know how this works. And GED, this one out here. This already feels like I'm going to be doing something very similar to the last one because they're giving me a similar situation. Additionally, angle ABC, this one up here, is congruent to angle EDC, this one up here. And then AC is congruent to EC. Now, knowing that they gave us this piece of information, what is likely that we are going to end up doing with all this? Now, even if we don't know how we're going to get there yet, what's likely going to happen? Colette.
What's it called? AAS.
Okay, I feel the same way, but how did we get there? What made you realize that?
Because you can see that with the two different angles, that BC and DEC are congruent because they're linear pairs.
Okay, so we've got linear pairs here, and we've got linear pairs here, just like we did on the first one. And what happened when we had those linear pairs is that we started off here, we realized that we had two congruent angles, and it ended up that the other sides right here would end up congruent as well. That's what just happened to us earlier. So I kind of feel like this might be the exact same thing. And if we did get that, if we were able to accomplish that, we would have AAS. So just a heads up as to where we might be going. Sometimes it's kind of nice to be like, well, what is this likely going to be?
Wait, how would we have AAS?
Well, remember, if we could get this angle here and this angle here, we would have two angles matching two angles and a non-included side. So that's what I'm kind of feeling. Now, I might be completely wrong. We might get there and be like, oh, whoa, we don't have enough information with this. We might have to go back. But let's give it a try. Let's see where this can take us. Now, we might have to do a lot of the same things that we did last time because this is a very similar problem. Amber.
So you're going to do angle DEG.
DEG.
Or I guess you can do it.
This is my first step? This is what you...
Sorry. You're going to do the given angle FAB.
Okay, let's all take a minute and write the given. We're all going to write the same thing, so... GED. Don't forget to change this, because I changed that. So that's what makes it all possible. Angle ABC congruent to angle EDC. And also line segment AC congruent to line segment EC. And all that is given. And whenever you're ready, Amber.
Okay, so you're going to do angle FAB.
Angle FAB
Plus angle BAC.
plus
Or CAB.
plus angle CAB.
Is equal to 180.
Just like we did on the last one, we used a linear pair to make that connection. Can we get both like linear pairs in one shot here? Can we just do them on one line to save ourselves some work? Okay.
And we're going to do angle GED plus angle CED is equal to 180.
I'm going to zoom in here. I know that's small for you guys, so I'm zooming in. And how will I explain that?
The linear pair postulate.
Linear pair postulate. All right, perfect. Now remember, our goal at the end is that we want to be able to say that angle CED, that this one right here, actually let's not go there yet. Let's do the same step that we did last time first, and then I'll explain what's about to happen. So now what did we do once we had these two things? Like, what was our purpose of having two sentences that were both equal to 180?
So we can get angle CED and angle CAB alone.
Right, but how do I connect them? I need to connect these things. Like last time we got here, we had a way of connecting them. How did we do that?
It says
Look at what's right there. I think you'll get it. Like, what is just? It's just this line. We just need to make a connection on this line. Help her out.
It's substitution property of equality, because instead of both equal 180, we can put angle FAB plus angle CAB is equal to angle GED plus angle CED.
Bravo. Angle GED is congruent as plus angle CED. And we did that through substitution or the transitive property, whatever you prefer to call it. I tend to just go with substitution all the time. It kind of covers most of the bases there. Like, it's the safe one to go with. All right. Now our goal when all this is said and done is to be able to say that these two things are congruent to each other. CAB and CED. This looks so much like what we just did. This is like, oh my gosh, this is the exact same proof, just with different things there. Talk to me.
You can make the FA, you can change the GED to FAB.
Okay, so she's saying, let's take this let's turn this you said GED, right? We're going to take GED, and we're going to turn it into, we're going to turn it into an FAB using this line right here. We're going to take GED and swap it out. So let's do that. Angle FAB plus angle CAB is equal to angle FAB plus angle CED. What is our purpose in doing that? Like, what is our ultimate goal? Like, where are we headed with this?
To make CAB equal to CED.
Right. So, but why did we need this and this there? Why was that, like, what was it? Why did you make that your goal? You're totally right. Why? Because we're hoping to subtract it away.
But
Be-
why can't you just put that that's transitive? Isn't that what you're doing in transitive?
We're just doing substitution here. We're taking out the GED and putting in an FAB. We're taking out one thing. We're not making a connection between two statements. We're just doing this right here.
Okay.
All right. So that was substitution. Like, we pulled it out. That GED changed into an FAB. Now what are we doing? Yes, ma'am.
Angle CAB is equal to angle CED.
CAB is equal to angle CED. How did we end up there? Subtraction. Okay, so now we've got this. You've proven to me all of those things. Now what?
Didn't we prove that they're equal, not that they're congruent?
Okay, so we could go, yeah, we proved that. So let's add one more. Good point. CAB is congruent to CED. What would be that reason? Definition of congruency. So now we've got that they're congruent. And now what are we going to do? How are we taking this home, Amber?
Well, I'll tell you in a minute, but I have a question
Okay.
before that. Okay, so 2 steps up, why is that subtraction? Like, can transitive be right? Because technically we are taking out 2 things that both of them have in common.
Notice this. So here's the thing. This stayed exactly the same. Didn't change. This stayed exactly the same. Didn't change. The only thing we did was pulled out a GED and put in FAB using this very first statement we had right there.
Okay. So now you're going to do angle ABC. Is congruent. I mean triangle, sorry.
Beautiful.
Is
Good catch.
congruent to triangle ABC. Because of
You got it. Take a second.
angle side angle.
So that means that there are 2 angles with a side in between those 2 angles. Is that what we have?
Wait. Yeah.
So it would look like
It's legal.
we're saying that you've got 2 angles, and right in between those 2 angles is a side. That would mean that you could prove to me that this is congruent to that.
Oh, so then it's angle, angle, side.
Angle, angle, side. So not that one. It's angle, angle, side.